Hello students, today we are going to study the motion of objects under the influence of gravitational force of the earth. This is the topic that we are going to study today. Now we know that in the first chapter of that is motion, we have studied that three equations of motion. The first equation of motion is V is equals to U plus AT, and the second equation is S is equals to UT plus half AT square. And third equation of motion is V square minus U square is equals to 2AS, where U is initial velocity, V is final velocity, A is acceleration and T is time, and S is the distance covered. But if we consider these motion of the object under the influence of gravitational force of the earth, that means when we throw an object upward, it comes down. So in that case, the equation of motion will change slightly and we'll be writing V is equals to U plus GT, where G is the acceleration due to gravity. And the second is H is equals to, this we are changing this equation, H is equals to UT plus half AT square, we are writing H is equals to UT plus half GT square. That means H is the height, maximum height reaches by a stone. So instead of distance covered, we have written height, and here acceleration is there, and this is acceleration due to gravity. And third equation of motion will change into V square minus U square is equals to 2GH. A is acceleration and this is acceleration due to gravity. S is the distance travel and this is also the distance travel, but this time when we take a vertically upward or downward, that will be the height. So these are the three equations of motion modified under the motion of the object under the influence of the gravitational force of the earth. Now let us solve some numerical based on it. Now the first numerical is a ball is thrown vertically upward with a velocity of 49 meters per second. Calculate the maximum height to which it rises and the total time to return to the surface of the earth. Now in this question it is given that a ball is thrown vertically upward. So U is equals to 49 meters per second. So when it will reach to the top, the final velocity will become 0 and then it will start falling down. The acceleration due to gravity is minus 9.8 meter per second square. Now whenever an object is thrown upward, the acceleration due to gravity will be negative, and when it is coming down, the acceleration due to gravity is positive. So that's why we have written a negative minus 9.8 meter per second square. Now we have to find the maximum height to which it rises. Now we know the formula V square minus U square, this is third equation of motion, is equal to 2AS. So instead of A we are writing G, and instead of S we are writing H. So the formula is V square minus U square equals to 2GH. Now what is the final velocity? 0. Initial velocity 49. So 49 square is equal to 2 into G minus 9.8 into H. So H will be equals to minus 49 into 49, and this is 2 into minus 9.8. This minus will cancel here, and 49 into 49 upon 2 into 9.8. When we will solve this, this will become 122.5 meter. So the height, the maximum height to which the stone will rise, a wall will rise is 122.5 meter. Now we have to find the total time to return to the surface of the earth. Now we know the formula again, that is V is equals to U plus GT. Now here again the final velocity is 0. Initial velocity is 49 minus 9.8. Acceleration due to gravity is minus 9.8 into T. Shift this side, it becomes 9.8 T is equals to 49. So T will be equals to 49 upon 9.8, that is equals to 5 seconds. Now we have to find the total time to return surface of the earth. So it will take 5 seconds to go up to reach the highest point, and while returning it will take again 5 seconds. So total time will be 10 seconds. So we'll write total time to return to the surface of earth surface of earth will be 5 plus 5, 5 for going up and 5 for coming down, so total time will be 10 seconds. Now let us solve the question number 2. A stone is released from the top of a tower 90.6 meter. Calculate its final velocity just before touching the ground. Now object is falling down. So initial velocity is 0 and it is having a height of 19.6 meters. So h is 19.6 meter, and since it is falling down, so acceleration due to gravity will be positive, and that will be equals to 9.8 meter per second square. And we have to find the final velocity, that means just before touching the ground what will be the velocity. Now again we will be using the third equation of motion, v square minus u square equals to 2gh. V is final velocity that we have to calculate. U initial velocity is 0, so we'll put 0 here. 2 into g is 9.8 into height is 19.6 meter. So v square minus 0 is v square is equals to 2 into 9.8 is 19.6 into 19.6. So we'll calculate v is equals to under root of 19.6 into 19.6. So when we'll solve it, v will be 19.6 meter per second. So the final velocity just before touching the ground is 19.6 meter per second. Now let us solve the question number 3. A stone is thrown vertically upward with an initial velocity of 40 meter per second. Taking g equals to 10 meter per second square, find the maximum height reached by the stone. What is the net displacement and the total distance covered by the stone? In this question, a stone is thrown vertically upward. So initial velocity is given, that is 40 meter per second. When it will reach the highest point, final velocity will become 0, and the acceleration due to gravity will be minus 10 meter per second square. Generally the acceleration due to gravity is 9.8, but in this question it is given taking g equals to 10 meter per second square. But since it is going upward, the acceleration due to gravity will be negative, so minus 10 meter per second square, and we have to find how much height it will reach. So first we will find the maximum height. V square minus u square equals to 2gh. V is 0 square minus u square, that is 40 square, is equals to 2 into minus 10 into h. So we'll solve this. Minus 40 into 40 upon 2 into minus 10 is equals to h. This minus and minus will cancel, 0 will cancel, this will become 2. So h is equals to 80 meter. So the maximum height reached by the stone is 80 meter. And now we have to find the net displacement. Net displacement. Now you can see in this question that when it goes up and it will reach down, so the initial and final point will be the same, so the net displacement will be 0 meter. Now we have to find the total distance covered. Total distance covered, it reach the highest point up to a distance of 80 meter and will return 80 meter back. So 80 plus 80, the total distance will be 160 meter.